Let's talk for a minute about chemical versus physical properties. Chemical properties are things that can only be changed using a chemical process, and they result in a new substance. Physical properties refer to things like state of matter, or malleability, or whether or not something is wet or dry, things like that. Here's a couple of examples. If I take this piece of paper and I burn it, then I'll have a new substance. That's a chemical process. But if I take this piece of paper and I just rip it into little pieces, that's just a physical change. Here's another example. If my Powerade freezes in my car overnight, that's a physical change. It's just going from a liquid to a solid. The next day, it'll melt and turn back into a liquid. However, some of the ingredients of Powerade include magnesium chloride, calcium chloride, potassium phosphate. I can't just pull those things out without a chemical process. Atomic mass is another piece of information found on the periodic table. Mass means how much does the atom weigh? This is measured in AMUs. The number that's given for lithium at 6.94 is an average of all the possible masses of the atoms of that element. Isotopes are different types of an element with slightly different masses due to different numbers of subatomic particles. What's in an atom's nucleus? Neutrons and protons, right? However, one type of atom can have different numbers of neutrons and protons. This is represented with isotope symbols, like lithium-5, lithium-6, lithium-7. Those are all types of lithium. The atomic mass of lithium is 6.94 because that's an average of all of the possible masses of lithium. You can use this to determine how many neutrons there are in one atom of lithium. And use the example of lithium-7. We know that lithium has an atomic mass of 7, so we start with atomic mass. We know that it has an atomic number of 3, so that's how many protons we have. We would subtract the number of protons from the atomic mass to determine the number of neutrons. So atomic mass of 7 minus atomic number of 3 equals 4 neutrons. Make sure you remember that this symbol doesn't mean lithium -7. It just means lithium-7. Now let's talk about ions. Ions are atoms that have a positive or negative charge. That's because they gained or lost electrons. Cations are positively charged ions. Anions are negatively charged ions. The way we show that something is an ion, not just a regular atom, is with a superscript. That's when the number is in the sky. So this is a carbon ion, carbon with a positive 4 charge. This is a hydrogen ion, hydrogen with a -1 charge. The charges are related to valence electrons. Valence electrons are the electrons on the outermost orbital of the atom. In this example, these 3. The 2 on the inside are not valence electrons because they can't be shared between atoms. Bonus points if you can figure out which element this is. Valence electrons brings us to the topic of ionization energy. Ionization energy is how much energy it takes to remove an electron from an atom. So high ionization energy means it's more difficult to remove electrons. More stable atoms have high ionization energy. Low ionization energy means it's easier to remove electrons. Less stable atoms have low ionization energy. On the periodic table, ionization energy increases as you move left to right, or from the alkali metals towards the noble gases, and it also increases as you move from the bottom towards the top.